Day 58 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again another day, another LeetCode problem. You already know how we do. We're getting to it like there's nothing to it, guys. So before we start, don't forget, guys, don't forget, bring a mouse, bring a mouse, bring a mouse, bring a mouse right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and hit that like button for me, guys. Then after you hit that like button, go ahead and drop a comment in the comment section. I'm talking about one of those bank emojis. I need all of my bankers out there to go ahead and drop one of those bank emojis in the comments so we could grow this community, bring some engagement to this channel, and bring some knowledge and awareness about the Swift community. You know what I'm saying? Now, with that being said, guys, the main event, the part we've all been waiting for, the question. And the question we have here today is question number 547, number of provinces. The difficulty level is medium, but you guys already know we're not gonna let that stop us. And I think this would be a good question because it's actually not that difficult. The question is one of those things where the question is harder to understand than the solution. So let's break it down. Let's break this question down and see what solution we can come up with today. So the question says there are N cities. Some of them are connected while some are not. If a city A is connected directly with city B and city B is connected directly with city C, then the city A is connected indirectly with city C. A province is a group of directly or indirectly connected cities and no other cities outside of the group. You are given an n times n matrix is connected where is connected ij equals 1 if the I city and the j city are directly connected, and is connected ij equals 0 otherwise. Return the total number of provinces. So let's break that down so we can understand what they mean. Let's look at example 1. Example 1, we have the input is connected and we have the list of cities. So first, let's break it down. This right here, this is one city, this is two cities, or this is the second city, and this is the third city. So when we look at the first city, what we're going to do is, so we're going to look at these integers because these integers are going to let us know what city that this first city is connected to. So this is the first city. We're in the first city now. This represents the first city, so 1. So obviously the city is connected to itself. That's why it equals 1. If you look up here, city 1 is connected to city 2. That's why right here, city 2 is equal to 1. Or, yeah, and it's right here, city 2 is equal to 1. Then we're going to check city 3, which equals 0, and it equals 0 because it is not connected. City 1 or city 2 is not connected to city 3, so we're going to put a 0 to represent that is not connected. Then we're going to do the same thing for city 2. And remember, so this is city 2, and these integers in city 2 represent if we're connected to all of the other cities or not. So right now we're in city 2. We're checking to see, is it connected to city 1? Yes, it is. So we put a 1 right here. We're checking to see, is it connected? Is city 2 connected to city 2? Yes, it is. It's connected to itself, so we put a 1 right here. Is city 2 connected to city 3? No, it's not connected, so we put a 0 right there. Then we do the same thing for city 3. This is city 3. First thing we do, we check to see, is city 3 connected to city 1? No, it's not, so we put a 0. Then we say, is city 3 connected to city 2? No, it's not, so we put a 0. Then we come down here, is city 3 connected to city 3? Yes, it's connected to itself because it's itself, so we're going to put a 1 right there. So the output would be 2 because there are 2 provinces. So city 1 is connected to city 2, so that's its own province together because they're both connected, so they both become their own province. That's 1 province right there. And then city 3 is over here on its own. That's its own province as well. So that's the second province. So City 1 and City 2 make up the first province because they're connected, and City 3 is its own province, so we only have 2 provinces. City 1 and 2 is a province, and City 3 is its own province, so the output is 2. So let's look at example 2, just in case that didn't make a whole lot of sense. We'll break it down one more time with city 2. So we have it's connected, and then we have our array of integers, our 2D array of integers, and we're going to check again. So first, this array inside of the array, but this first array inside of the bigger array is represents city 1. So we're going to check city 1 to see what it's connected to. So is city 1 connected to city 1? I mean, it's itself, so of course it's connected to itself, so we're going to put 1. Is city 1 connected to city 2? No, it's not, so we're going to put a 0. Is city 1 connected to city 3? No, it's not, so we're going to put another 0. Then we're going to move down to city 2. Is city 2 connected to city 1? No, it's not. Is city 2 connected to city 2? Yes, because it is city 2, so they're connected. Is city 2 connected to city 3? No, it is not, so we're going to put a 0. Then we're going to move down to city 3, and we're going to do the same thing. Is city 3 connected to city 1? No, it's not, so we're going to put a 0. Is city 3 connected to city 2? No, it's not, so we're going to put a 0. Is city 3 connected to itself, city 3? Yes, it is, so we're going to put a 1. But the output is 3 because there are 3 separate provinces. None of these cities are connected to each other, so this city 1 is its own province, city 2 is its own province, city 3 is its own province, which gives us 3 provinces, which is why the output is 3 as compared to this one. City 1, in example 1, city 1 is connected to city 2, so that's one big province. They're not 2 different provinces because they're connected, so it's just one big province. Then we check city 3, it's not connected, so it's its own province, so we only have 2. So hope that made sense to you guys. But now let's get excited because we're about to complete the fun part, which is the actual code. So let's break down how we're going to code this. The first thing we're going to do is we're going to declare constant n and say let n equals is connected dot count. Then we're going to come down here, declare a variable, and we're going to call that variable visited, and this is going to let us know which cities we've visited already, and we're going to set that equal to an array repeating, false. So what that's going to do is going to create an array, and it's going to set each value. We're going to start basically with a default value of false because we haven't visited any cities yet. So we're going to set that to false. Then we're going to say count, and we're going to set that as n, or we're going to cast that as n. Then we're going to come down here, and we are going to say declare another variable called province or provinces, and we're going to set that equal to 0, and that's going to represent keep count of how many provinces we have came across already. So now that we've done that, we're going to declare another function inside of this find circle num function. So just remember that this new function is still inside of this find circle num function. We'll declare a function called DFS for depth first search. Then we're going to create some parameter or a parameter, and we're going to call that city, and that city is going to be an integer. Then we're going to come over here and we're going to say for neighbor, in 0 up to n, and remember n equals is connected dot count. We are going to say if is connected city, is connected, then we're going to put city, and then we're going to come over here and we are going to put neighbor, and then we're going to come over here and we're going to say is equal to 1. And remember guys, from the description, this is coming from here right here. Basically, is connected city neighbor is the same as is connected ij equals 1. But we're saying if, this is the if statement. So we're saying if is connected city neighbor equals 1, but we're going to say and, we're going to say exclamation point visited, excuse me guys, my spelling is off this morning, visited neighbor, we are going to say, exclamation point visited neighbor, we are going to say visited, then we're going to say neighbor, then we're going to set that equal to true because we have now visited it. But remember, we started we started it as false because we hadn't visited yet. But now we're looping through, and so if these conditions are met, then we're gonna say visited neighbor equals true. Then we're gonna come down here, do a little recursion, and we're gonna say DFS neighbor. Then guys, that's just the first part. Because then we're coming down here and we're creating a for loop, and we're going to say for city in 0 up to n letter n. We're going to say if exclamation point visited city, then we're going to say provinces plus equals 1. So that means we found a city, and we're going to add 1 to the count of provinces so we can keep track of the count. Then we're going to say visited city equals true. So we know not to, we already visited. Then we're going to come down here and we're going to say DFS city. Then we're going to come down here and we're just going to return the number of provinces that we found. And that should be it, guys. Let's run it and see what happens. Fingers crossed. Oh, compile error. What does it say? Typo. I tell you guys, my spelling is off this morning. I don't know why. Visited city equals true. Let's run it again. Oh, we didn't get it on the first try, but it's all right. We got it the second try, so let's submit it and see what it says, guys. Fingers crossed. Let's see what it says. 72 milliseconds beats 44.94% of users with Swift. Now, that's not bad, guys, but we could do better. We're going to get those numbers up. It just takes time. We have to be patient, and we'll get there. We'll get there when we get there, but no rush. But guys, get the solution one more time. This is the solution. This is the code. Get that good code. And I'll see you guys tomorrow, guys, for another day, another LeetCode problem. See you then.